So we continue with the week two tutorial, and we're going to have a question regarding the instantaneous center of zero velocity. So we've been given the example for the automobile that's traveling in a straight path at the 12 meter per second velocity. We need to determine if there's no slipping occurs. We need to determine the angular velocity of one of the rear wheels and the velocity of the fastest moving point of that wheel. So the plan is we need to follow the problem solving procedure as we're going to see next. What we need to do in that case is going to be, first we need to find the IC, which is going to be at the ground since there is no slipping occurs there. Now to sketch that, maybe this image is not very clear. What we are going to do is we are going to sketch the first velocity that is starting with the point B. Start from point B, going to the left as 12 meters per second. Then I'm going to sketch the other velocity, which is going to be the V maximum. Okay, going to the same direction. They are acting on the same line of action. Now, of course, we can have a line that connects between the starting of these two velocities, and we're going to sketch a line that passing through the ends of these arrows. Its intersection with this vertical line is going to give me where the IC is. Now definitely it's going to be the ground. So the IC is going to be here. Now you can see that we have a triangle. This triangle, we're going to have the large one and we're going to have the small one. Obviously the omega of that link, PIC, is going to be equal to the velocity here, 12 meters per second, perpendicular velocity, divided by its length. Its length from P to IC is the 350 millimeters or the 0.35. So the omega is V over R. The V is 12 meter per second and the R is 0.35. So we just substitute that and we're going to get that the omega is going to be 34.3 radian per second. Now this omega is going to be the omega of the whole triangle. The omega of the whole triangle, we're going to consider that something like a plate. Now I would like to calculate what will be the V maximum when the R is going to be equal to 2 times 0.35 from the point, from the point here to the IC. And that's the velocity. So I can find we know the omega now. So I can simply apply the equation that said that the V maximum is equal to the omega multiplied by the D, which is 0.7. So the 34.3 radian per second multiplied by 0.7 meters is going to give me what will be the maximum velocity, which is 24 meters per second. That's it. It's very straightforward. Of course, if I'm going to have the ground is going to have a slipping, then the things will be changed. If I'm going to have velocity at the IC, then I'm going to have this velocity. I need to know what's its direction, and I'm going to resketch the IC, and I'm going to find it and do the same thing. I'm going to have triangle, and I'm going to make a proportional relationship between the triangle sides, and I'm going to have all the unknown parameters.